Hi friends, let's solve this problem. An angle of intersection of the curve x square by a square plus y square by b square is equals to 1 and x square plus y square equals to ab, where a is greater than b is, so we have to find angle between the curve given, which is one is an ellipse and another one is a circle. So finding an angle between the curve is nothing but finding the angle between their tangents at the point of intersection. So that is how we measure the angle between the curve. So for finding the angle, now we require tangents at the point of intersection. So the first task will be to find the point of intersection of the curve x square upon a square plus y square upon b square equals to 1 and x square plus y square equals to ab. So by solving simultaneously, we will find their point of intersection, and then after finding their point of intersection, we are going to find the slope of the tangent at the point of intersection. Okay, finding a slope is nothing by calculating dy by dx in for both the curves. We will calculate the value of dy by dx at the point of intersection. Then by using the formula tan theta is equals to mod of m1 minus m2 upon 1 plus m1 m2 to get the angle between the two tangents. That is nothing but the angle between the two curves. Okay, so this is the overall idea. So now let's start. So the first task we are going to do is to find the point of intersection of the two curves. So we can get the value of x square from the one curve and we can substitute in the another curve. So from here we find the value of x square. So value of x square turns out to be a square minus a square y square by b square. So now let's substitute this value in the next curve. So we get a square minus a square y square upon b square plus y square is equals to ab. So then we get y square into 1 minus a square upon b square is equals to ab minus a square. So then we get y square times, we can just cross multiply this. So we can even write this as an a square minus b square upon b square. This is equals to a square minus ab. Okay. So then we get y square value as y square is equals to then by simplifying, I think we can just use a square minus b square formula, which is a minus b a plus b, and here on the right hand side we can take a common, so a minus b gets cancelled, and what we are left with a b square upon a plus b. Okay, so the value of y, so this implies the value of y is b square root of a upon square root of a plus b. Okay, this is the value of y. So now let's find the value of x. So by using the equation 1, we get x square is equals to a square minus a square by b square, and the value of y square is a b square upon a plus b. So now this is equals to, we can take a square common and this b square gets cancelled. We are left with 1 minus a upon a plus b. Okay, so then this is equals to, we are left with a square b upon a plus b. So this is our x square. So then the value of x is a, then the value of x will be a square root of b upon a plus b. Okay. So now we know the value of x and y. So the coordinate x comma y means the point of intersection. So the point of intersection is a square root of b upon a plus b comma b square root of a upon a plus b. Okay, this is the point of intersection. It's the point of intersection. Point of intersection. So now let's find the slope of the tangent at this point for both the curves. So once we know the slope, we can use the tan theta formula given above. to get the value of angle or to find the angle. So now let's consider the first curve, which is x square plus x square by a square plus y square by b square is equals to 1. Let's differentiate with respect to x. So we are going to get 2x upon a square plus 2y upon b square. Here it's going to be dy by dx. We are differentiating y with respect to x. So now this is equals to 0. So by simplifying, we get dy by dx value is equals to minus 2x upon a square into b square upon 2y. So now here we substitute the value of x and y. So what we get is minus, so here this 2 and 2 will get cancelled first. So this is going to be minus b square a square root of b upon a plus b upon, then this is a square, and then the value of y, it's a b square root of a upon, or we can write it as a square root separately, upon square root of a plus b. So the square root of a plus b gets cancelled. Okay, and by simplifying we can easily see that we get the answer. It's a minus b square root of b upon a square root of a. So now let's take this slope as an m1. Now let's consider another curve, the second curve, which is x square plus y square is equals to ab. Okay, so now let's again differentiate with respect to x. So what we are going to get? We are going to get 2x. We are going to get 2x plus 2y dy by dx is equals to 0. So the value of dy by dx, is equals to minus x by y. And then by substituting the point of intersection, we get dy by dx is equals to minus a square root of b upon b square root of a. So now let's take this slope as an m2. Okay, so now let's calculate the angle between the two tangents, but as we know the slope of the tangent. So the value of tan theta is equals to mod of m1 minus m2 upon 1 plus m1 into m2. So now by substituting the value of m1, which is minus b square root of b upon a square root of a plus a square root of b upon b square root of a, it's upon 1 plus b square root of b upon a square root of a multiply by a square root of b upon b square root of a. So now by simplifying, okay, it's easy to, this b will get cancelled, this a will get cancelled. Okay, so we are left with b by a, and then in the numerator by cross multiplication, okay, or by taking LCM, we get a square root of b into a minus b square root of b upon, it's a b square root of a. It's going to be ab square root of a. So in the denominator, what we are left with? We are left with a 1 plus b by a. So it's going to be a plus b by a. Done. So now by simplifying, I'll write it here. So now this is equals to, so we have tan theta equals to mod of, then we are left with the square root of b bracket a minus b upon b square root of a. Okay, as we can see that here in the numerator we are getting a square minus b square. Okay, by taking square root of b common, so it's a minus b and a plus b. So a plus b and a plus b will get cancelled. So then we are left with this. Okay, so then we get tan theta is equals to, and here also the square root of b will get cancelled, so we are left with the tan theta is equals to a minus b upon square root of ab. Okay, so then the value of theta, which is the angle between the two curves, it's a tan inverse of a minus b upon square root of ab. Okay, so the option b is correct. Okay, it's a tan inverse of a minus b upon square root of a plus b. Now, an important question that may arise is that while taking the square root here, correct, while for calculating the value of x and y, for calculating square root, while taking the square root of x and y, we have taken only positive square root. Okay, even for calculating value of x and the calculating for value of y here. Okay, both we have taken a positive square root. The reason is that if ellipse, the first one is an ellipse and another one is a circle, if both the diagrams or both the curves are symmetric along the x-axis, even they are symmetric along the y-axis. So if suppose if we consider the point of intersection in the first quadrant, so the angle between them, or if they intersect in the third quadrant, the angle between them is going to be the same, just because the graph is symmetric about the x-axis as well as the y-axis. Okay,